Three-dimensional containers. We are creatures that live and move through three-dimensional space, so we are very familiar with the many types of containers: boxes, bottles, cans, and so on. If one of us is evil... Whoa! Wait, how do we know that this bird is evil? Ah, there we go. Then any container that is closed on all sides, the top and the bottom, can serve as a prison. Punk. There you go. Now we imagine that our evil creature can fly, so that the container must close up the full 3 dimensions of possible movement. If this was an evil person, high enough walls, high and slippery enough walls will keep them in. You don't necessarily need the top, so it doesn't fully contain a 3-dimensional space. But by dealing with a bird, we clearly have to contain all of the dimensions of movement. Now, what we will call an empty 3-dimensional box will be the surface of a cube without any of the points inside. And to draw a cube, the first thing you do is draw a vertical line, and then you try to draw a horizontal line that is the same length, because if you want it to be a cube, you want all the sides to be the same length. And then you complete this off into a square. So you start with a square, and then you draw a diagonal line off from one of the corners in such a way that it's going to be about the same length as those two sides that you started with. Then you draw another line parallel to it off of another one of the vertices, and you connect that down. You'll know that it's long enough when you can draw a vertical line straight down and close it off. And then you draw a parallel line to the front, and you make that long enough that if you make a horizontal line would be parallel to the front, a diagonal up like so. And then usually to imply that it's a hollow box, we put sort of a dashed line going down and kind of complete sort of the square that we can't see the back of the box, and then you run a dashed diagonal down. I've decided I'm going to require you to know how to draw a box. If you get nothing out of this class but how to draw a box, you will thank me for the rest of your lives. Anyway, this is a slightly weird object. It's a mathematical object because the walls of a mathematical cube are paper thin, thinner than paper. It's as thin as a speck of a point is wide. So if you couldn't really contain something in this, unless it was infinitely strong, because you could just tear through it like wet tissue paper. But it's an infinitely thin object. Mathematics deals with these weird creations. Anyway, a solid 3-dimensional box will be a solid cube. One way to indicate that it's a solid cube is that you can kind of sort of not see the back corner. You can also shade in the sides. What I'm going to do is I'm going to write the word solid next to any solid cube to imply that it's like a grain of salt. It's a solid 3-dimensional object. It's not hollow in the middle like this last one. Now, I'm going to leave it to you to figure out how many vertices a 2-dimensional box has, but I'll start you off by labeling a few of them on a unit cube. Unit cube is a 3-dimensional object. We need an x-axis, a y-axis, and a z-axis. Again, now here, all of the sides are going to be parallel to one or the other axes. That's parallel to the y-axis, that's parallel to the x-axis, that's parallel to the x-axis, that's parallel to the z-axis, and we so construct a box. That point right there is the point 1, 1, 1, because it's 1 out in the x direction, 1 over in the y direction, and 1 up in the z direction. That point there is the origin, 0, 0, 0, and this point up here is, let's see, we don't go forward in the x-axis, we stay x equals 0, then we go over to y equals 1 and z equals 1, so that is the point 0, 1, 1.